Okay, today we're going to be talking about the distance, rate, and time word problems. So I'm sure you've seen D equals RT, which is distance is equal to rate times time. And for many of these problems, when you think of the units, it helps you solve them. So distance, let's say, is in miles, could be different. Your rate would be miles per whatever time, usually miles per hour, times the time, which would be the unit of hours. So if you notice, hours is in the numerator and the denominator. So when that gets multiplied, it's crossed out, and then miles would equal miles. So using your units will help you solve these problems. The first three problems are pretty easy. So we have you are eating Oreos at a rate of 5 Oreos per hour for 8 hours. How many Oreos did you eat? So for this one, we don't have distance. So instead of distance, we have the amount of Oreos being eaten. So let's make that Q. We can't do O, it'll look like a 0. So let's do Q equals total Oreos. So our equation is Q equals your rate times time. And for that, we have Q is equal to, my rate is 5 Oreos per hour, and my time is 8 hours. So the hour unit cancels out, and Q is equal to 40 Oreos. And that's how many I eat in 8 hours at that rate. Next, we have a problem saying you have been on a boat for 8 hours and have traveled 56 miles. How fast, this should say, is your boat going? So this one we do have distance equals rate times time. The information we have 8 hours. That would go in the times lot. And we've traveled 56 miles. So 56 miles equals rate times 8 hours. So to figure out what our rate is, we would divide both sides by 8 hours. And your rate would be 56 divided by 8, which is 7. And your units are right there, miles per hour. Okay, last one, that's a simple problem. It says you are biking for 30 miles at a rate of 8 miles per hour. How long have you been biking? So again, it's a distance equals rate times time. I've been biking for 30 miles, so that's my distance. 30 miles equals 8 miles per hour, so that's a rate. 8 miles per hour times t. And it's asking how long, so yes, we're solving for t. To get t alone, we can multiply by the reciprocal of 1 hour over 8 miles, because that cancels everything out on this side. Usually you would think about just dividing by 8, but since I'm using the units in this problem, we have a fraction with our units. So the miles would cancel. And yes, essentially you are just taking 30, dividing by 8, and the units that are left are hours. So the time the boat has been, or you have been biking, not the boat, you've been biking for 8 goes into 30 3 times, and you have 6/8 remaining. So 3 3/4 of an hour. Okay, let's take it up a notch. So for this particular problem, Mary is painting rooms and Kevin's helping her out. So we have Mary is painting rooms of her new house before she moves in. It takes her 4 hours to paint one room. Her friend Kevin is going to help, and it takes him 3.5 hours to paint one room. Her house has a total of 8 rooms. So how long will it take them to finish painting? In these type of problems, it's helpful to draw a chart. So we have our two situations, which would be Mary painting and Kevin painting. Each of them will have their own rate, time, and rate times time equals the total something. It's not distance in this particular problem. We'll make it Q again, but Q would stand for the total rooms. So the total amount of rooms that they have been able to paint. So let's look at our rate. So if we have, let's look at our equation. Q equals RT. So Q is the amount of rooms. T is, we have a unit of hours right here, hour. So that means when we multiply by the rate, hours needs to go in the denominator and rooms needs to go on top. So if it tells me that Mary paints one room in 4 hours, her rate would be 1 with the room, 4 next to the hour, so her rate is 1/4. And Kevin paints one room in 3.5 hours, so his rate would be 1/3.5. We normally don't leave a decimal or a fraction within a fraction, decimal within a fraction. So if we multiply this by 2, we get 2/7. All right, time will stay the same. They're going to paint at that rate for however long. And then we get the total amount of rooms that they've painted. So that would be Q equals rate times time. So when we take Mary's information, it would be 1/4 times T. Kevin's information would be 2/7 times T. So they're working together. It's not going the opposite ways. One's not undoing the other one's work. They're working together. So in math, together, we're going to add them. And we're going to make that equal the total amount of rooms that they're going to paint. Well, together, they'll end up painting 8 total rooms. So now let's solve for T, and that will answer the question that they were asking, which is how long will it take to finish painting? All right, so I think the easiest thing would be multiply by 28 to clear our fractions. So 28 times 1/4 gives us 7. We have 7t plus 28 times 2/7. Well, the 7 would cancel. This would go to 4. 4 times 2, we have 8t equals, and we still have 28 times 8. 28 times 8 is 224. So combine your like terms. 15t equals 224. Divide by the 15. And it's going to take approximately, if you put in your calculator, 14 and 93/100ths of an hour. So almost 15 hours to paint the entire house. All right, next problem. Mark and his brother David are fighting over a top airplane while playing in their yard. Mark grabs the plane and takes off running at a rate of 7.5 miles per hour. 1 minute after Mark starts running, David starts to chase him at a rate of 9 miles per hour. How long will it take David to reach Mark, and how far will they have run? All right, so we have two situations. We have Mark running and we have David running. So let's make a table here. So we have Mark, David. They're going to have their own rates that they're running, their own time. And this one is a distance problem, so we'll just make it equal to distance. Okay, so for Mark and David, you're really, for these problems, we're just really need to concentrate on the rate and the time. And then the distance is those two multiplied together. So for Mark, Mark runs at a rate of 7.5 miles per hour. So we can mark that into 7.5 miles per hour. And he'll run for however many hours we say. For David, he is running at a rate of 9 miles per hour. So 9 miles per hour, and his rate, the amount of time he's running, it's different than Mark's because David starts up 1 minute after Mark starts running. So his time is going to be different. He's going to take away 1 minute, but you have to be really careful. You're not just going to write t minus 1, because if you look at everything, it's 7.5 miles per hour, and it's 9 miles per hour. So we need to stay consistent. If we subtracted 1, that would mean t minus 1 hour, but we want to do t minus 1 minute. So 1 minute would be, if our t is hours, then we have 1/60th of an hour. And that's starting 1 minute later. Okay, so the distance for Mark would be 7.5 times t, because remember, d equals r times t. So I'm just multiplying rate times time. And over here we have 9 times t minus 1/60th. The question is, how long will it take David to reach Mark? How far will they run? So they want to know how long will it take to reach. That means that they're together, equal. So let's take these two and make them equal. So 7.5 t equals 9 times t minus 1/60th. So when we distribute, we get 9t minus, 3 goes into both of them. So we can do 3 here, 20 there, so minus 3/20. And on the other side, we still have 7.5t. I'm going to subtract 9t from both sides, and I'll get we have negative 1.5t is equal to negative 3/20. And then negative 1.5 can be thought of as negative 3/2. So to get rid of that, we can multiply by the reciprocal, negative 2. Sorry, this should say 2/3. So that'll cancel. And over here, the 3's cancel, and our time is going to equal 2/20, which is 1/10 of an hour. And if 1/10 of an hour would equal 6 minutes. So from there, that's the time. It's going to take 6 minutes for them to reach each other. That's the first part of the question we need to answer. And then how far will they have run? Well, distance, we can plug the 6 minutes, but we want to look at it as the hour rate, back into either of these D's. I think the top one is a little bit more simple. So we'll do D equals 7.5 times time. So D is equal to 7.5. And since our time unit is hours, let's use 1/10 of an hour. So you end up getting, if you look at this, we have 7.5 over 10. So when you divide by 10, you move your decimal over to the left. So 3/4 of a mile. So in 6 minutes, they finally reach each other. And at that point, they've run 3/4 of a mile. Next one, we have Heather rows a boat upstream, then turns around and rows back downstream to her starting point. It takes her a total of 5 minutes to do this. The current is moving at a rate of 3 meters per second, and Heather can paddle at a rate of 7 meters per second. How far down the river did she go before turning around? So for these, I like to do a picture. But first, let's make our chart. And we have two situations. Yep, they're both dealing with Heather, but first we are rowing upstream. And then we're going downstream. Okay. So when we're rowing upstream, Heather rows a boat upstream, then turns around and goes back. It takes her 5 minutes to do it completely. Great. The current is moving at a rate of 3 meters per second, and she is paddling at a rate of 7 meters per second. So her rate is different for both situations. And the reason why, yes, she herself, when she's going upstream, she's paddling at a rate of 7, meters per second. However, that's not exactly how fast her boat is going because she has the current that is going against her at 3 meters per second. So truly her rate when she's going upstream would be 7 minus 3, which gives her a rate of 4 meters per second. And then when she goes downstream, okay, she's traveling or paddling at 7 meters per second, but she's got the current going with her. So it's actually pushing her 3 meters per second faster. So now downstream rate would be 10 meters per second. Okay, so this whole entire trip took 5 minutes. So we're actually given the time rate. So we have to be careful here. So we'll say, okay, time is time. But if the total time is t, when we take this, we actually have to say, we're going to take away the time from the total, which was 5 minutes. And I'm not going to write 5 minutes there. Why 5 minutes? I don't want to write 5 minutes because everything we're talking about deals with a different unit for time, which is seconds. So I need to make my minutes into seconds. So 5 minutes would be 300 seconds. So I'm going to take 5 minutes total, take away the time it took upstream. And if that's confusing, think of it this way. You have your 300 seconds minus t. If you add t, that's a total of 300, which is your 5 minutes. So your upstream and your downstream should be together 5 minutes, which when you take and add the 2 times, we get 5 minutes. Okay, so for D, for going upstream, we have 4t. And then for the distance going downstream, we have 10 times parentheses 300 minus t. Okay, now she travels the same distance upstream as she does downstream. So if they're the same distance, we can make the distances equal to each other. So 4t equals 10 times 300 minus t. So we have 4t equals, and then we distribute, we have 3,000 minus 10t. I'm going to add 10t to both sides. I'll get 14t equals 3,000. And then when we divide by 14, your time is equal to, well, Let's divide and simplify them both by 2. So 1500 over 7. And we have seconds. And if you throw that into your calculator, instead of throwing that into your calculator quite yet, I mean, you can, but it says how far down the river did she travel. So this is time, but I want to know how far, the distance they travel. Well, she traveled down and then back. So distance would be one of these because that's half of the trip. So we'll do 4 times time, which we got 15 over 7, 1500 divided by 7. So we would do 4 times 1500 over 7, and you get 857.14 in distances in meters. All right. Those are pretty long notes for now. So what your homework will be is to finish the rest of these. So work on those, and then the answer key will be posted online.